Here we look at a very special limit, the limit as x goes to 0 of 1 plus x to the 1 over x. We're going to derive this limit formula by taking the derivative of f of x equals the natural log of x at x equals 1. So we can actually calculate this limit. F prime of x equals 1 over x, and so f prime of 1 is 1 over 1, which is 1. But we also know that f prime of 1 here is the limit as x goes to 0 of f of 1 plus x minus f of 1 over x. And this is the limit as x goes to 0 of the natural log of 1 plus x minus the natural log of 1, which is 0, over x. And using the rules of logarithms, we see that the limit as x goes to 0 of the natural log of 1 plus x over x is the limit as x goes to 0 of the natural log of 1 plus x to the power of 1 over x. And now we know that this limit equals 1. If we apply the exponential function to the limit on the left, we get e to the power of the limit as x goes to 0 of the natural log of 1 plus x to the 1 over x is equal to e to the power of 1, which is what we get when we apply e to the right-hand side. Now, looking carefully at the left-hand side here, we have e to the limit as x goes to 0 of the natural log of 1 plus x to the 1 over x is the same thing as the limit as x goes to 0 of e to the power of the natural log of 1 plus x to the 1 over x. And the reason for that is because the exponential function is continuous, so we can interchange it with the limit. And now, of course, e to the natural log of anything is the thing itself, so we're actually looking at the limit as x goes to 0 of 1 plus x to the 1 over x. And applying the exponential to the right-hand side of the equation above, we get e, so we get e equals the limit as x goes to 0 of 1 plus x to the 1 over x. Now, if we substitute y equals 1 over x in this limit, we get that as x goes to 0, y goes to infinity, assuming x is positive. We get the limit as y goes to infinity of 1 plus 1 over y to the y is equal to e also. In particular, if n is an integer, that's the counting numbers 1, 2, 3, etc., as n approaches infinity, 1 plus 1 over n to the n approaches e. And we can look at a graph here of this sequence. For n equals 10, we see a dot representing 1 plus 1 over 10 to the 10, which is 2.59 roughly. We also have a dot for n equals 100, and we have the value of 1 plus 1 over n to the n is 2.7048, and we see as n increases, this 1 plus 1 over n to the n doesn't go beyond the horizontal line y equals e. In fact, this graph of dots, 1 for each integer n, looks more and more like that horizontal line as we move to the right. So the limit as n goes to infinity of 1 plus 1 over n to the n is equal to e.